Hi, this is Alex from devstories.eu. GeoDjango and PostGIS, Episode 9 of 15. Forget writing massive coordinate comparisons. You have a user location and a delivery zone, and you need to know if they overlap. Doing this mathematically means checking hundreds of polygon edges in your application logic. Instead, GeoDjango reduces this entirely to a database operation. Today, we are mastering spatial lookups. If you have used Django, you know the double underscore syntax for filtering query sets. You append something like double underscore exact or double underscore in to a field name. GeoDjango extends this exact same syntax to execute complex PostGIS topological relationships. Topological relationships are just rules about how geometries share space. Are they touching? Are they overlapping? Is one entirely inside the other? GeoDjango gives you dedicated lookup types to ask these questions directly in your ORM queries. The most common and forgiving spatial lookup is intersects. If you filter a geometry field with double underscore intersects, the database returns records where the two geometries share any portion of space. They can cross, they can touch at a boundary, or one can completely envelop the other. As long as there is any shared space, intersects evaluates to true. Often, you need more precision than a simple intersection. You need strict boundaries. This is where contains and within come into play. Developers mix these two up constantly. Here's the key insight. The difference is purely directional. If geometry A contains geometry B, then geometry B is within geometry A. Think of a box and a marble. The box contains the marble is within the box. You choose the lookup based on which geometry is in your database column and which geometry you are passing as the filter argument. Consider a concrete scenario. You have a database table of houses, and each house has a point geometry representing its location. The city just released a new polygon defining a designated flood zone. You need to find all the houses that sit perfectly inside that risk area. You do not query the flood zone and see what it contains, you query the houses. You call filter on the house model, reference the point geometry field, add double underscore within, and pass the flood zone polygon as the value. When you execute that query, Django translates your double underscore within lookup into a native PostGIS function call, specifically st.within. The database engine evaluates the geometries using its optimized spatial indexes. It checks if every single coordinate of the house point lies inside the interior of the flood zone polygon. If the house sits exactly on the boundary edge of the polygon, it is not considered within. Strict containment means the interior of the first geometry must be completely inside the interior of the second geometry. If you reverse the scenario, say you're querying a database table of neighborhoods to find the one that surrounds a specific user location, you use double underscore contains. You filter the neighborhood polygon field, add double underscore contains, and pass the user point. The logic is identical under the hood, but the order of the spatial arguments passed to PostGIS is swapped. Understanding this directional logic prevents silent failures and empty query sets. By mapping PostGIS operations directly to Django keyword arguments, you filter massive spatial datasets efficiently without writing raw SQL. The geometry you are filtering against always dictates the direction of your spatial lookup. Thanks for tuning in. Until next time.